Hello and welcome back to PTV Talks. I'm Adam Lynch and I will be your speaker today. And I'm also with Bill Sisko, who will be your moderator behind the scenes, manning the Q&A and chat. This session's topics is on innovative and alternative interchanges. And for me, this is very exciting to present because these features over the last several years in PTV Vistro have been building and building and building, making it possible for us to have this very discussion about these complex intersection types. So I'll be covering a lot of information today in this advanced course, this advanced topic. So if you're not getting it, there's a lot of basic information that we had with the previous PTV talks over Vistro. So you can review that and then maybe catch up. But so I will be moving very quickly through this presentation just based on time to hit all the points. But you'll have access to this recording, and please, please, please review this recording and share it with your coworkers or your clients or even agencies where you see a benefit to use Vistro for these alternative designs. First, we'll be highlighting some of the Vistro 2021 features that make these designs possible. And then I'll cover modeling tips and resources that helps you develop these designs. And of course, we'll see some simulations along the way. All right, so Vistro 2021 is just over a week old now. So if you haven't updated yet, please do. This will allow you to access these new features that we're talking about today. For all the feature details, you can check out our What's New document that's linked here in this presentation when we share it with you, or you can find it on the start page within Vistro itself. And of course, please sign up for the Vistro UGM session where again, we can go over these features in a little bit more detail than what's in this presentation. But as most of you know, PTV Vissim, it's an extremely powerful microsimulation tool. So this improved integration that we have with Vistro and Vissim 2021 is groundbreaking. It opens up a lot of opportunities for analyses and to create these out-of-the-box simulations that you're going to see today. And of course, this integration is part of this urban mobility system concept that we're working on at PTV. And if you would like to learn more about this concept, please visit the link that's on this slide, and that will go to a knowledge base article. The next feature that we have is a model merge and a update feature. This feature will help you minimize rework within your projects, and perhaps maybe you can put in existing models into a current model. For example, since we're talking about advanced interchange types, you can put an example file of an advanced interchange into your current project. So it's a great feature to kind of get you started. Again, please look at the help document on this that's been updated, and that will guide you through this feature. Next, we have a traffic signal controller list. And so with alternative interchanges, you can have a lot of different controllers that you can generate. So within this list, you get to see what the signal ID number is, and you can change the signal ID number now. And then also you can see what intersection that signal is connected to in this list. And then next, we have two very important visual features. We have a crosswalk and we have a stop line setback feature. And I'll highlight how these are used today when you see this into the examples. This feature helps size the intersections that you see in Vistro visually. And then when you go into Vissim, this data is used to size the intersection in Vissim as well. So it's an important two features. And then to go along with this, we have a corner radii visualization feature. So in Vistro, you can now see the different radii, which you couldn't do previously. And this radii, it's used for HCM6 analysis, but will be imported into Vissim for the actual connector radii that you see. So it's a really cool feature there. This feature here is for vehicle miles traveled or kilometers traveled, depending on which units you use and where you are in the world. This is a trip generation tool. So if you use a path that is between the zone and a gate, you can now get the VMT or the vehicle miles traveled per path or total across the project. For the advanced intersections, maybe like a CFI or a U-turn, this could help you understand how much further somebody may have to drive to navigate through the intersection, and then you'll have this VMT metric to report. Okay, so here's a list of the alternative intersections that I'll be covering today. Many of these types now have an example file in an alternative intersection folder in the release, the 2021 release. So maybe you can use that again to merge into a project using that merge feature. And there will be a few of these coming soon that we've previously worked on to get ready for this presentation that we'll be putting into Vistro within the next service pack or so. So there's a lot of really good resources out there for alternative designs and some modeling practices. FHWA has a collection of info guides, and they recommend signal phasings and perhaps some safety considerations and how to handle pedestrians, things like that. So that's a good resource to dig into. VDOT has, Virginia DOT has a great summary of brochures that can give you some ideas and real quick look of what these intersections, how they appear and what they look like. And then Missouri DOT, they have very cool videos of showing how these intersections operate. And so that's maybe something you can show a client or somebody in your office if you have an idea for one of these intersections. And then for us at PTV, we have a good knowledge base article that covers modeling tips for alternative designs in Vistro. And I'm going to highlight some of these tips, but please bookmark this link because today I don't have time to go through every detail and specifically how to model these things. I'll just be kind of picking out some of the highlights. So when modeling your alternative intersection or any project really, it's important to understand what your overall analysis objective is. This sets the scope and the depth of your model and kind of how you lay it out. For example, if you need to quickly test an idea or a lane configuration, you can just create a schematic as you see in this top picture right here. You don't need a lot of details. But if you want this detailed micro simulation, you'll need to add extra details in the Vistro, such as medians and maybe the exact curvature along the roadway. For a SPUI example that I'll be talking about a little bit later, I'll illustrate how this step in understanding the analysis is important from the beginning. But once you add these extra details into your model, you get an awesome simulation like this. Right out of the box in Vissim. I mean, you can see that the vehicles are driving in the lanes. When this left turn clicks on this dual left, you'll be able to see that people are respecting the turn. So it's pretty nice. And it's also nice to have pedestrians crossing the street if you have pedestrians in your model. Okay, so step 2 is to identify the building blocks that you'll need, and of course, understand how it'll impact the simulation if you go that route. First, you need to ask the question, do I need a bi-directional leg? And you'll see this a little bit further on in the presentation. Or do you need a one-way leg? And then you'll see how this can be an impact. So for example, if you have a bypass road or something like that, which we'll show in our green T intersection, this is an example where you might need a one-way leg instead of a bi-directional leg. All right, so the next question you would ask is, can I combine intersections to minimize how many I need? using like this approach offset feature that I've highlighted on the right, this is able to kind of combine like offset T intersections. You can reuse this also for alternative intersections. And then step 3 is to plan and place your building blocks ahead of time. So here you can determine exactly how many intersections or how many you need for your design, what control types you might need for your design. And if you have a numbering scheme that you have to follow for your design, you can kind of plot it out early before you get too far into connecting things up. So this is a pretty important step. And there is a footnote that I have here. Unknown intersection types don't provide all of the details that you may need for advanced intersections. So you may need to switch the control type to like maybe always stop or something to access things like medians and lane widths. And then when you're done, you can switch it back. Step 4, this is when you start modifying your custom intersections that you have laid out. There are a few tips you can follow. Tip 1 is create your lane configurations first before you start connecting legs together. And this is important, for example, because if you have 3 outbound legs at an intersection and you want to connect it to another intersection that has 1 inbound leg, you'll get 2 exit pockets or lane drops that will form. And with these exit pockets and lane drops, that's just extra work to get rid of them. So what you want to do is make sure you have the lane configurations first. And then tip number 2, which you may already know, is when you want to create the poly points after you connect the legs, and some of you probably are laughing already about this, but it's really important to connect the legs first to your intersections and then create the poly points, or else you'll lose the poly points when you snap the legs together. And then for tip number 3 here that I'm going to highlight today is it's very likely that these alternative intersections have special overlap phases that allow, maybe you catch up from a U-turn intersection to the main intersection, and that's represented in an overlap phase. So here on this traffic control workflow tab that I have open, there's a plus icon where the circle is, and this will open up the signal groups window. And here within this window, this is where you can enter these special overlap phases, and then they become accessible in the sequence and for the overlap auxiliary menus and things like that. So it's important to put it into this signal groups window if it's that case. Okay, so we're going to go into poll number 2 and 3, Liz.
All right, thanks, Adam. So poll 2 is, how often do you need to perform simulation as an extension of your deterministic modeling analyses? All right, so it looks like the most popular answer is most of the time, so over 50% of that time. And then now we are going to go into poll 3 here, which is your current simulation tool capable enough to create and properly simulate advanced intersection configurations to satisfy your project needs? All right, so the most popular answer at 65% was yes, and you use a PTV tool. All right,
Wow.
Thank you all for participating in the poll. So I'm going to give it back to you, Adam.
Okay, well, that's good to hear, those poll results. And so hopefully the rest of this presentation will fit right in. So let's jump into the examples, how we can apply, the tips and tricks that I've just specified in the last section. These are, again, the examples that we're gonna go through just for a highlight. So we're gonna start with the green T intersection. So this intersection has a five legs at the signalized center. And then what I was using was 2 merge and diverge intersections circled in red here. And this is used to separate the through bypass movement from the signalized movement. And yeah, this all, of course, operates under one controller at that main intersection. And so when you zoom in a little closer, you can see that the left turns are actual individual legs, and you can see that the through actually does bypass the intersection. And how all of this came about was with the highlighted rows that you see in the table. These are those new features in 2021, Vistro 2021 that I talked about. We have the stop line setback and the radius. We're using these to actually get this set up. And then going into the simulation, this out of the box green tea coming from Vistro into Vissim, and this matches up the geometry specifically on the base map. And you can see that it's a really nice presentation straight out of the box. Okay, next we have the Rcut intersection, or restricted crossing U-turn intersection. The Rcut restricts the cross street traffic from turning left or actually going through, so it forces everybody to turn right from the cross street, and then they go down to a median U-turn intersection that's signalized, or even sometimes maybe not signalized, depending on the volumes. But so they go down to this median U-turn intersection and then come back. FHWA provides some signal phasing ideas, and the link I have on this slide. And we're using the one scheme here that is for one traffic controller. And you can see just kind of the ring barrier structure and phasing that I've included in this model on the slide. And when we zoom in a little closer to the intersection, again, you can see that we're utilizing those Vistro 2021 features to bring the left turn out from the intersection and provide the different radii for the intersection. So, I mean, this looks pretty good on the base map. I like it. And then when you go down to the U-turn intersection, it's using the same features to create that, and you're able to pull off the U-turn in its own separate turn bay and kind of create like the same bypass through like you did in the green T for the top through movement there. And that way, that intersection is able to operate like it's supposed to operate. And again, I'm going to show a video. Yeah, again, we're matching the background straight out of Vistro, and it's providing a pretty high quality simulation and showing the vehicles where they're supposed to be. Okay, the next intersection type that's coming in right now is the median U-turn, or the MUT. I don't think anyone calls it the MUT that I know of, but I know it as the Michigan left. So if you're up in Michigan, you know this intersection. This restricts all the lefts at the main intersection in the middle, and it sends all of that left traffic again down to a median U-turn. So it is similar to the Rcut, it's just doing a slightly different thing. However, in Vistro, we need to have two signal controllers for this case because of how FHWA's guidelines put the U-turn in the middle of the ring. There's a red box shown on the phase diagram that FHWA had in Exhibit 5.4. That's the U-turn phase. And since Vistro's left and U-turns are forced to have a lead or a lag, not having the barrier here in this will force that U-turn phase to be in the front or the back. So here we need two controllers to kind of get around this, and that way we have the U-turn in the middle, but it works. And then here is the simulation again. So it should be coming on your screen really soon. This is actually pretty cool because this is the same as the Rcut intersection that you just saw, but it's showing a different alternative on top of that. it's showing this Michigan left or MUT alternative. So you can see how it's really powerful within Vistro, where you have scenario management. You can create one intersection and then the other intersection, and then have two powerful out-of-the-box simulations to show your customers. All right, the next intersection that's coming in real soon, yep, loaded up, is the displaced left turn intersection, otherwise known as the CFI intersection or continuous flow intersection. I think this one has many names. This intersection type is really flexible, so I would highly recommend reading the FHWA guidance here to determine what configuration you may need for your project type, and again, what type of signals, timings, and number of controllers that you may need at your intersection type. You can run it with one controller or two controllers, and there's different pedestrian configurations. So again, please take a look at this document. This example that I have shown here is a partial displaced left turn intersection on two approaches, the north-south approach. This is a real intersection in Utah. And just this one requires 5 intersections. And at the main junction, which I'll zoom into in a second, you'll be able to see how that's broken into sub intersections, and then you'll see the crossover locations and stuff as well. So at the main intersection, we utilize the new features again to kind of create this approach offset, and we use the stop line setbacks to make sure all the stop bars are in the correct place at the main intersection, and we use the radii to kind of show, you know, the control so people can't turn where they're not supposed to turn. So I mean, we've used all the features here within the CFI, but it's amazing that we can create it and actually fit within the right-of-way on the image here. And then the next slide that will be coming in is a close-up of the crossover intersection. And at this crossover location, you see how this bypass right turn kind of blows by the displaced left intersection. So we actually have 2 separated movements next to each other, plus the main street. So again, it's really cool that we can get all of these movements close together and stay within the limits. And then the last intersection, it's a really basic merge point for the right turn. It's kind of hard to see at the scale, but the turn just kind of comes in like it would for an entrance ramp on a freeway or something like that. And then now I'm going to be playing the CFI video. I had this on LinkedIn, so if you had a chance to see that, you've seen the video running. But again, just pointing out that we can develop this simulation from Vistro into Vissim, staying between the lines. And I would have to say this is very difficult for many simulation packages to do. But as you can see, it works well within our urban mobility system at PTV. And now we're moving on to the interchange types of this presentation. The first one we have is the SPUI, or the single point. This one that I have shown here is more in a schematic form. It's just 3 basic intersections to handle the center where all the lefts cross over, and then how the rights come in. So it's 3 intersections here. They're all put onto one signal controller within Vistro, and it's using this basic 3-phase controller. And so the results from Vistro using HCM and all of this, it's near perfect. I mean, it's great results that we have. But there's always the but. So this is a good time to bring up rule number 1 that I said before. Rule number 1, understand your analysis objectives. So if you want to take the SPUI that I have in the schematic form on the left side and put it into micro simulation, you start running into a few issues. And one of the issues that we have is where I have circled on the Vissim model and where I have circled on the Vistro display is where the rights come in and come off. This creates one really large intersection here. And the problem is that on the Vistro side on the right, I'm sorry, on the Vissim side on the right, it kind of truncates the storage that's actually out in the field here at this location. And so that storage bay is shrunk, and it's not exactly how you would want to simulate this within Vissim. So taking my lessons learned, knowing that, you know, my objective is to show simulation here, this is exactly the case where you would want to consider putting in a one-way leg on each side of the intersection. And by putting in this one-way leg here, you can shrink down the right turn junctions, the diverge of the right turn on the bottom, and the merge of the right turn on the top. You can shrink these intersections down. And as a result, this actually does allow this the storage for this left turn to be created with showing the realistic conditions that you would have in the field in Vissim. So it's a simple fix in this case, but again, I point this out more or less on purpose that if you want to do this simulation, you have to kind of think ahead of time and know how to code the one-way leg or the bidirectional leg and what the impacts could be on the Vissim side. And then lastly here, we have our Diverging Diamond example. So FHWA has pretty good information on diverging diamonds. And again, it varies on if you want to use one controller or two controllers for a diverging diamond. It really depends on the core size. That's what's in the middle of the interchange. It's either a bridge or under a bridge. But that core size for a diverging diamond is more or less like the vital lifeblood of the system. If that queues up and fails, then most likely everything is going to crash within your diverging diamond. So careful attention needs to be looked at within that core section of a diverging diamond. And that often will be the deciding factor if you want to use one controller to progress traffic through, or if you need two controllers with a bigger offset to progress the traffic through. So just be aware of that. But again, to test the core, often you don't want to go through this whole exercise of piecing everything together and then say, oops, I need 3 lanes or 4 lanes within the core of my diverging diamond, or I need an extra left or an extra right. It's really good to test these things before you start connecting things together. So on this slide here, it shows the power of Vistro to just basically put in an intersection and just do the general HCM calculations or deterministic calculations to say I need 3 lanes, 4 lanes, 1 lane to make this intersection work. Okay, and so you can do that on all of the different intersections within your diverging diamond. And then when you connect everything together, you have a better chance of this diverging diamond to actually work. So you can think about, you know, before you would use Vistro, like you could do a diverging diamond in Vissim, and by doing this in Vissim, you would have to, you know, add a few lanes. You would have to run simulations multiple times. You maybe have to tweak a few signals multiple times. So it could take quite a bit of time to actually pin down the configuration that you want if you just jump straight into micro simulation. The power here with Vistro is that you can do most of that testing ahead of time. And so just tinker around in Vistro and build it in Vistro and then put it in the micro simulation. So this is a really big advantage with these complicated intersection types. And then after going through all the steps that we talked about, again, 1, step is identify and place your building blocks. Well, I guess the first step was to figure out what your analysis, how deep you were going to go. But then you identify and place your building blocks. And then you can go in and modify each individual intersection by saying this one needs 3 legs or this one needs 4 legs. And then you can put in the lane configurations for each leg that you need. And then you connect up the intersections together. And then you can go in and put in the curvature. And after going through these very logical steps, you get a DDI like this in Vistro with pretty minimal effort, actually, to do something like this. And then at the end, it actually fits on the base map within Vistro, and it makes a great presentation to your customer from a Vistro report. But then, as an added benefit, you can get this DDI in the micro simulation, where a lot of the testing has to happen anyway, and it will save you a lot of that extra work for your project. So in the end, using Vistro and Vissim together in a combined environment basically is going to allow you to make micro simulation possible for almost all budget projects. So projects where you traditionally said, hey, I don't have budget to do micro simulation in some degree, now you can do it for pretty much all projects. And so that's pretty amazing. And then one other fun fact about DDIs, I mean, since it's pretty much broken into one-way legs anyway, the resulting Vissim layout is a pretty nice layout. So on this video, you can see that step 1 here is that you would put in, you would kind of test your MOEs and see how this DDI behaves. Maybe you'll change some of the signal timing as you go through here. You can go check the other terminal here, and by checking the other terminal, then you can verify if it's all right on that side. And then after it's okay there, you can say, hey, you know, maybe I want to put in some signalized routes. So you can draw your optimization routes within the DDI and get a time-space diagram created within Vistro showing what your core movements and coordinations look like. And then also you can do the same thing in the ramps of the DDI. So you can see how your ramps progress through the core. So Vistro gives you a lot of options before you get to Vissim to make sure that this intersection is optimized and timed to be successful on the Vissim side of things. I'm gonna, yep, so we typed in the eastbound, the westbound, the ramps here. Okay, so the next thing that's going to come up is the Vissim Preview. So you can access just the basic preview window within Vissim. And this Vissim window will let you know maybe if you coded something wrong or maybe a radius needs to be changed. And also maybe like you forgot a detector or something like that. So it can be a spot check to make sure you've coded Vistro correctly. And then of course we have the A&M export. And with this A&M export, it will open it in Vissim itself. And you start getting a lot of these powerful features, such as the aerial backgrounds, which will provide a lot of context to how everything fits on the base map. And you can, once the lanes fit on the base map, of course, you can go into other design packages like Lumen RT or 3D Studio Max and create those great, amazing visuals that you want to create for a project like this. You're on the lane, so it's going to be on the lane in those applications. So yeah, it's really exciting for me to present these types of features, and it's all coming together so you can drive on the lanes in Vissim coming from Vistro. And so I'm pretty excited that we can present you Vistro 2021.